center of mass, the object moves forward. I translate it, right? I can even do that diagonally, see? You know what I'm saying? I can push through if I push through the center of mass, it goes in a straight line. The force is acting through the center of mass. Now, if I define an axis, here's an object. Let's say I define an axis, and all an axis is just a fixed point, right? An axis of rotation. Right? If I define a point that I'm going to fix here, and now I apply a force, okay, that causes a rotation. So torque is a force that acts at a radius from a fixed point. All right? It's a force acting at a radial distance from a fixed point. Torque equal to a force acting at a radial distance, okay, from a fixed point, which we call the axis, right? The axis of rotation, right? An axis of rotation. All right. Okay. So here's an object, this door. Here's a fixed point. The hinge, right? I apply a force. The force is applied at a radial distance from, so this is a radial distance. And so as I apply the force, it rotates, the door rotates. It's rotating, this point is rotating in a circle. It's a radial distance. Okay. R times F, torque then is R cross F, which is RF sine phi. Right? Make this magnitude. RF times the sine of phi. It's a cross product. Torque is a vector. This is the magnitude of it. And the direction is from the right-hand rule. We did cross products, right? Remember that? The right hand. So when you have two vectors, they form a plane, right? And you're either above the plane. Your direction's either above the plane or below the plane. So it's R cross F. So in this case, R is out. This is my axis. R goes this way. F is that way. So it would be R cross F, and the direction of the torque is down for this. We didn't cover torque. You'll be forever ignorant.
No, because I'm so.
You know what's going to happen, Basile?
No.
You're going to go to a cocktail party, and the subject of torque is going to come up. So you'll have to quietly slink away. And they'll say, oh, he was in Professor Barry's class, they didn't study torque. You know what I'm saying? Yeah, they can't let him work on any rotating projects. It's all anything. Anyway, did that help you?
Yeah.
So here, with the pendulum, you have a force, right, acting about a fixed point. So where is that? Here. See this? The force that pulls the pendulum back is due to gravity, right? this is the component of the force. This component is balancing the tension, right? Gravity is always pointing straight down. This component is balanced against the tension, and this component, see, this is an unbalanced force, right? So therefore you get motion, mass acceleration. Anytime you have this force balances that, right? The tension is balanced by this component of gravity, but this is not balanced, and so this is a torque because it's a force acting. This is the fixed point. This is your axis of rotation. This acts at a radial distance. See the arc there? See the arc here? So that's the torque. This is the arc length, right? The arc length is the length times the angle, usually in radians, right? Remember all that stuff? Kind of all comes together in physics, you see, in engineering. It all comes together. See, doesn't it? Huh? Well, that's the interesting part. Very precise, actually. Okay, but so that's a torque. Torques are confusing. It can be. In the end, it always goes back to what is torque? What you keep going back to. When you struggle with something, you have to keep going back to the definition. Okay, what is torque? What is torque? You get it clear in your mind. What is voltage? What is current? Say, what is voltage? Say, we'll study that next time.
What is the current? What is the current?
It's the flow of charge.
No, I don't.
Oh.
I want to hire you, so it is my engineer in my company. So, what is the current?
Current is V divided by R.
No, see, that's a math definition. That's a math definition, which is okay up to a limit. All right, well, let's take a break. I think we've been rambling. Yeah.